What's up everybody, this is Wallace from A3Academy, and today our topic is going to be vector addition. So let's get started. So in our scalars and vectors video, we said that a vector is a mathematical construct with both a magnitude and a direction. Now suppose we had a vector with a magnitude of 5 meters and a direction of 30 degrees above the horizontal. This is an example of a vector with both magnitude and direction. Now, you can split up a vector into component vectors. These vectors are known as the x component and the y component. And the x and the y component define the vector itself. In order to find the x and y components, you can use basic trigonometry. Suppose we define this vector in terms of generic variables. We call the vector a, the magnitude of the vector r, and the angle theta. In this case, the x component vector can be shown as a sub x equals r cosine theta. And in the same way, the y component vector can be represented as ay, which is equal to r sine theta. So these really simple formulas can give you the x and y component vectors of any vector. And these components are really helpful when you're adding together vectors. Now, you can represent a vector using its x and y components like this. This is known as the ordered pair notation for vectors, where the first number is the x component and the second number is the y component. So, here's an example problem. Write the ordered pair notation for a vector v with a magnitude of 6 centimeters and an angle of 240 degrees above the horizontal. Now, before we even get started, notice that the vector isn't actually above the horizontal, but is instead swept out 240 degrees from the horizontal. We measure the angle 240 degrees from this horizontal line, and we measure it counterclockwise. We can break this vector up into its component vectors. The x component, as we said earlier, is a sub x, which is equal to r cosine theta. R is 6 centimeters and theta is 240 degrees, so plugging in these numbers gives us negative 3 centimeters. In the same way, we can use the formula for the y component to find a sub y, which is r sine theta. R is equal to 6 centimeters and theta is equal to 240 degrees, and so in that way we should get that ay is equal to negative 5.196 centimeters. Therefore, the ordered pair notation for this vector is a sub x, a sub y, or negative 3, negative 5.196. Now, the addition. How do you add two vectors? Well, suppose we had a vector with components a sub x, a sub y, and another vector with components b sub x, b sub y. If you wanted to add these vectors together, all you have to do is add the x components and the y components. It's literally that easy. So, to wrap the presentation up, let's go over one in-depth example problem. An object experiences the following forces. One force at 25 newtons at negative 16 degrees from the horizontal, one with 14 newtons at 252 degrees from the horizontal, and one at 10 newtons at 118 degrees from the horizontal. What is the net force on the object? Now, remember, as we said in our scalars and vectors video, a force is a vector. Now, this might sound like a very complicated physics problem, but the truth is, if you want to find the net force on an object, all you have to do is add the vectors of the forces. So our plan is to find the components x and y of all three of the vectors, add them all up, and find the resultant vector, which will be the net force on the object. Let me label each of these vectors with a letter that corresponds to the letters in the problem. Now let's tackle this one vector at a time. So let's split this vector into its component vectors. The x component is going to be r cosine theta, which is going to be equal to 24.03. The y component is going to be r sine theta, which is going to be negative 6.89. Therefore, you can use the ordered pair notation for this vector, which is going to be 24.03, comma, negative 6.89. The next vector, vector b, we can do the same thing. We can split vector b into its component vectors. B sub x equals r cosine theta, which is equal to negative 4.32, and the y component b sub y is equal to r sine theta, which is equal to negative 13.31. Again, we have b sub x and b sub y, which means we can find the ordered pair notation for this vector is negative 4.32, comma, negative 13.31. Now we can tackle this vector, vector c. Let's split this up into its component vectors. C sub x equals r cosine theta, which is equal to negative 4.69, which is the x component of the vector. The y component is going to be c sub y equals r sine theta, which is going to be equal to 8.82. So we have found the ordered pair notations for all three of our vectors. Now all we have to do now is add them up, and we will get the ordered pair notation for our resultant vector, 15.02, comma, negative 11.38. Now, this doesn't really help us very much because it just gives the ordered pair notation of a vector and not its magnitude or its direction. So how can you find the magnitude and direction of this vector given the ordered pair notation? Well, we know for a fact that from the distance formula, you can calculate the magnitude of this vector using the square root of x squared plus y squared, where x is the x component and y is the y component. So we can just find that the magnitude is equal to, plugging these numbers in, 18.84 newtons. Now, to find the angle of the vector, we can use basic trigonometry to find that theta is equal to the arctangent, or the inverse tangent, of y over x, where y again is the y component and x is the x component. Plugging these numbers in, we get that theta is equal to negative 37.15 degrees. Now, with our information that we have obtained from our ordered pair notation, we have r equals 18.84 newtons and theta equals negative 37.15 degrees, which means that our resultant vector, or the vector that we get from adding all three of these vectors, is this. And this is the net force on the object when all three of these forces are pulling on the object at the same time. And that's it for today. Hopefully you liked our video, and as always, the more you know, the better you are.